and
Okay.
she'll be your point of contact, I believe, throughout it. All right. So with any system, we've got one controller. So that's really critical, and I'll kind of dive into how you tell apart the controllers and then the collaborators. But per system being a single curve, there's one controller and then multiple collaborators. And so you'll get, the controller goes on the front of the on the front of the curve, and then through the curve you use the collaborators. And these are all wireless devices. They all talk to each other through mesh net radios or device-to-device radios. And each performs a specific function. So kind of, like I said, get into that, but this is just a real introduction to the basics. You can also utilize radars at the beginning of the curve. Now, if you have two approaches to the curve, obviously from both sides of the road, and you want to highlight signage on both sides of the road, you would use two radars. So that's one or two radars, or the system can handle one or two radars. And then obviously we enhance the signage with LED rings and plates. So on the warning sign, we have a ring that just mounts within the border of the sign. And our product is kind of cool, and I'll show you kind of a graphic of this later on. But it just mounts to the sign face with the existing, or mounts to the existing signs or just standard signs with hardware you're already using, or some tape. In the case of the ring on the warning sign, there's some tape it mounts with. That makes it really easy to understand how these things mount. There's no special provisions or special mounting hardware. It's just what you're used to out in the field. So the controller, like I said, there's controllers and collaborators. It's really important to get the distinction down between the two. The controller, if you look at this image at right here, has a big green dot on it, and it says controller in the middle of that green dot. Let me see if I can zoom in on that a little bit. There we go. There's a big green dot right there. That is actually physically on the controllers, and you'll get one when you open up your boxes and see everything that's inside. You'll see these controllers. They're denoted by a part number M75-SA300-CTL 2 or 3, depending on whether you have a 20 watt or 30 watt panel. So these are the CTL units. They're kind of the brains of the system, so they handle all of the sequencing logic. They have the built-in meshnet radio, and they support the radar. They also handle all of the radar activation. So when you have, basically all the collaborators report to this unit and do what it tells them to do. The collaborators look very, very similar, but they're distinguished by a big red dot on the collaborator. And it says collaborator within it also. One thing to note that's really important is the unique collaborator ID on the label, or the manufacturer's label here on the back of the controller, or I'm sorry, collaborator. And that'll kind of play out later. I'll show you where that's useful and why you need to know that. But just know that on the back of that collaborator, what you're looking at here is the underside of a solar panel, and then the part that says TraffiCalm across the top, it has the big red dot on it. That's a box that houses all of controlling logic, the batteries, basically the engine of the unit. Everything plugs into that, and that is what I'll talk about. Went the wrong direction. There we go. I'll talk about a little bit later is the connections. But you can also hook up a radar to the collaborator. So if we have two entries to any given curve, we can sequence around the curve in two directions, but that would require two radars, or rather, depends if you want radar activation or 24/7 flashing, but it would require two radars, like I've said. So radar activation.
Hey guys. Oh, sorry, Andy. Can I interrupt you for 1 sec here?
No, yeah, that's great.
Just so you guys know, you do have radars on opposite ends of your sequence there. So you will be installing a radar on your initial chevron, and you'll be installing a radar on the collaborator on the opposite end.
Okay.
Do they have warning signs?
They do not.
No, yeah, they're curves, and Doc said in Houston they set them up for 0 miles per hour. So
yeah, that's fine. It just means it'll activate whenever there's a vehicle.
Yeah, that's basically what he said. I tried to sell him a 24-hour flash at that point, but
realistically though, you want to set it up more like 5 or 6. And the problem being that if you set it at 0, that actually dramatically increases the sensitivity of the radar to false detections. So you'll
Okay.
get a system that activates far too frequently for what the solar can handle. And there's other settings we can set up, sensitivities on the radars and stuff like that. But for the most part, you're probably going to want to set those up around 5 or 6 miles per hour.
Okay.
And I mean, I can't imagine anybody driving 5 or 6 miles per hour on any road.
No, probably not around here.
But,
You know, main thing I want to make sure, you know, this was the first time we were able to use y'all here.
Yeah.
Before, there's only been one other brand, and we kind of took a while to get this one through there and approved. And now we're actually looking at, we just did a huge curve sign without the flashers, like 1,700 of them across the 5 counties. And
wow.
they screwed up and put the wrong size up. They went with the
really?
standards, and a lot of the districts had already put up the bigger ones. So now the way
48 by 36 or whatever.
Yeah, we're trying to fix it by possibly just going through and adding the flashers on top of them to make them more visible instead of having to replace everything again.
Right. Yeah, and that's absolutely what our system excels at, is you don't have to replace the sign. It uses basically everything you've already got out there, with the exception you might have to put a post-top extension on to get the controllers and collaborators up high. But yeah, for the most part, you're just going to be able to use what you've already invested in to, which I think you know well what we're accomplishing here. But yeah, so the radar said at 5 or 6 miles per hour must be at the entry of both directions of that curve. So on one end you're going to have a collaborator, and on the other end you're going to have the controller, and then in between you'll have collaborators linking those two together. So the radar detects a vehicle approaching. You want to set to, I believe your only option is to set it to approaching, so it only detects vehicles coming at the system, and then starts sequencing away from that vehicle in, again, either direction. So if they're coming, let's say, north and south on a roadway, which actually wouldn't make sense, more of a west and north or whatever. I don't know. I'm not too familiar with how we determine curve angles, but it's just for simplicity, north and south. Somebody approaching south would have the chevrons would sequence away from them, and then again, somebody approaching from the north would have chevron sequencing away from them. And that's kind of a complicated concept, but we make it pretty easy in our setup and utilities there to make it pretty intuitive how you set up that bi-directional sequencing. That's what we've got an image here of is the sequencing or bi-directional sequencing. So when I talk about a system, I'm talking about all the hardware on a single curve. A single system can flash in both directions, and again, to flash in both directions, you only need 2 chevrons per post, or I mean, you will need 2 chevrons per post, but only 1 collaborator unit or controller. So the first post in either scenario, whether it's right or left, is going to be the controller, and then every other one will have a collaborator. Now, this only has 3 chevron sets in it, but you can go as many as you want to. I don't know how complex your systems get, but you can do 50, 60 of these things in a row if you wanted. So this talks about many systems include a curve ahead sign. Obviously, we don't need to talk about that here. So you're just going to be starting with the controller on a chevron post. So we recommend you do a chevron plan, and I intentionally did this kind of like hand-drawn because I want to just make sure that you guys know that this is where we usually recommend people start it, as just a hand-drawn map of every curve. And this is where those collaborator IDs come into play. So when you initially power on these systems and you configure them, you got to tell the controller which collaborators it's trying to connect to, and that's where those unique IDs come in. So you've got, in this case, I've got 4 chevrons, and they each have a unique number: 1, 2, 3, E65 being the topmost, E3B being the next one, so on and so forth. As you add those in, it's going to determine where they are in the curve. So the sequencing can be appropriate. You know what I mean? You don't want it to skip from number 1 to number 4, and then back to number 2, and then 3. You obviously want it to be all in sequence, and our system makes that really simple. And then, noting how many you have and where each belongs is really important. But when you power these on, they actually, let me step back. When you actually have the system installed in the field, the radios repeat. So number 1, as long as it has a good connection to number 2 and number 3, number 4, and so on, they're going to have complete connection and really good connection. But when you first power them on and before you've configured them, they don't have that repeating function. So what we recommend is you set everything up on the ground or the back of your truck, power it on, and then make a map like this and actually configure it without it being on the post. I know that adds one level of complexity, and maybe after you've done a few, you can see how they perform and try a couple different methods. But at least for the first one, and I would set it up like I said, on the back of your truck or on the ground, and get it fully functional, and then go put the controller and collaborators up on the post. This is also helpful if you have this map and you keep it handy for our support team to understand what's going on out there. It can really give us some insight into maybe a number's missing or some sort of breakdown if something stops working. So we really want to set you up for success, but we do have a great support team that will come in and help. On the phone if need be. So. Again, if you walk away from this meeting with any questions, I hope that I cover everything, but my support team I know will be able to help you through anything there. And this is one thing you can do, just shoot a picture off your cell phone of this, and that's a good starting point. So the installation of the system, controllers and collaborators, obviously being solar powered, mount near or at the top of the post. They mount to any post, side of pole or top of post, or we have a top post mount for 4-inch or larger systems, or 4-inch or larger poles, but everything else can mount to the side of post. Again, near the top though, so you maximize that solar exposure. You don't want it down, blocked by a sign. Solar is pretty finicky, so we don't want to obstruct it with trees or buildings or shadows. We really want to have it as much of a clear view of the sky as possible. So usually mounting it up at the top of the post. I've even seen situations where we've extended the top of the post to get that solar panel out of view of a shadow. So our system has enough cabling and flexibility to be mounted really anywhere on the post, but again, we're just trying to get it up above the signage at least. Wherever we can, we try to mount the cabling internally so that we don't expose ourselves to vandalism. The system, if you look at kind of the middle of that controller there, you can see a bunch of cabling exposed slightly right there, but that's just a really short run of cabling, and you can actually put some conduit over it or some loom over it to protect it even further. As we know, just any exposed cabling becomes a target for vandalism, so we try to hide as much of it as possible. Connections inside the unit are really, really simple. They're all well labeled. Look at the bottom of this slide here. That's the view inside the unit. It's not a great picture. I apologize, but it's what I had to work with today. There are 4 green connectors in there, and with little orange tabs. You press the orange tab down, you push the cable in, and that just captures the cable. It's really quick connect. Obviously, you need your cable stripped back, but there's connections there for your radar. And this is universal on controllers and collaborators. So same concept, same connections. In fact, you can't tell the difference between them because of the connections. There's input for the radar, where ECUs, there's AC terminations. There's outputs for A and B LED rings and plates. And that's important for you when you're setting up a bidirectional system. So everything going one direction needs to be connected to the A outputs, and everything going the other direction needs to be connected to the B outputs. If you mess that up, then certain signs will flash out of sequence because they've been connected to the wrong sequence of devices. So you want to make sure you got your A's and B's straight and connected. You can even note that on that hand-drawn map or the system of mapping that you've come up with, just to make sure that's all square. The battery and solar panel connections are made inside this cabinet from the factory, but you will need to install both your batteries and connect them. Now, there's 2 6-volt batteries in this system, and if only one's connected properly or only one's installed, then the system won't work. It won't have enough power to function. So it has to be that full 12 volts of power to function, but it's split into 2 small batteries. Keep the form and function small and compact. We've gone the route with 2 batteries. So again, if you've set it up on the back of your truck or on the ground, you got to make those connections. You don't necessarily have to have solar power. Everything ships charged, so as long as it doesn't sit on the ground or sit in the warehouse for very long, like 6 months or 7 months after that, you probably need to charge the system by putting it out in the sun. But if you're basically taking it from your dock and putting it up on the roadway within a couple weeks, you're going to have good charge on your batteries, but you will need to connect them. So if you're having problems or there's something that doesn't seem working right, those batteries are probably disconnected. There are some status LEDs inside the system. So there's a charging LED. In fact, you can see it twice in this slide. The amber LED inside the cabinet glows when the system's charging. There's also some activity monitor lights that you'll see. I think a red, white, blue light, if I remember correctly. And those will flicker based on just random activity. So when the sign's supposed to flash, I think the red one will flash with it. When the system is communicating with other devices, the white LED will flash. So you've got a lot of feedback there within the system, and not necessarily important when you're initially setting it up, but more important if you do need to support the system again. So you want to be familiar with where those LEDs are, and just know, especially the charging one. If it's not charging, that's a problem. So you want to make sure if you do have good sunlight out and that charging light is not moving, you might have an issue. So you want to check your connections on the solar panel there.
Hey, Andy.
So here's yeah, Karen.
Before you move forward, can you go back one to that original? Yeah. Quite often when I have been out in the field on installations, people ask me, and maybe you've already covered this, so I apologize, but people will ask me, well, how do I know what wires are plugging into which green connectors? Have you, that little diagram on the left side that's white, that clearly defines which connector is for radar, which is for, A and B and all of that, just so that you guys know.
Yeah, this picture's total garbage. You can't read those there. I need to get a better picture in that place, but very well defined which terminal strip is which. And some of the terminal strips, so I think the inputs and the outputs, not the radar input, but there's like a push button input for like a push to cross system, which we're not talking about here. But the inputs and outputs are expanded over onto an orange terminal strip where you can plug even more devices into. In this case, you've got your A and B signs plugged in, so you don't really need to worry about those terminal strips. You can just use the green connectors. But yeah, everything's well labeled within the unit, so you don't have to worry too much about connection. Getting things right though really trips people up. The radars, there's I think an orange, brown, red, and black wire. If you get any of those mixed up, especially the orange and brown, it's not going to function. So because I'm sure you deal with electrical connections all day long, it's critical to get those right. Otherwise, it's not going to work. And as long as the red and black are hooked up on the radar, it's probably going to show some signs of life, because that's the power in the ground. Will show some signs of life, so that complicates things even further. All right. Here we go. So here's how our sign plate mounts. You just use the bolts that mount the sign to the post. So like there's any special hardware or any special connections, there's one wire that shoots out the top of the chevron. And that's important to note that there are in fact right and left chevrons, and that's because the wire needs to come out the top of the chevron. Again, just to prevent vandalism, if it's a wire down at the bottom, somebody could reach up with scissors and snip it. As opposed to the top of the sign, they'll probably just miss it. It's there entirely. So you do want to make sure you got your right and lefts arranged properly. And again, you can open up all the boxes, throw them all in a pile in the back of your truck. As long as you have the wire shooting at the top, that's the only indication that it's right or left arrow or chevron. Radar aiming is not incredibly critical in this scenario. You can use the aim of the radar. I think this is kind of an older radar bracket shown here, but you can use the aim of the radar to exclude bad detections. So if we have nearby cross traffic, or maybe some really nicely blowing trees, or like fans will trigger the system, you can use the aim to exclude those. But for the most part, we want to aim this radar fairly broadly to capture as many approaching vehicles as far away as possible. So there's not really a measurement. I show it with a compass here, but it's not really a measurement that you can stick to that says this is the right angle to shoot your radar towards. Just down towards the roadway slightly and aiming towards oncoming traffic are the only two things that are important. if you set up the system and you notice that it's triggering off of what we call ghost detections or false detections, you could use the AIM to exclude those, and I would highly recommend that. Again, there's only so much battery, there's only so much the solar panel can do, and so we only want to activate the system when there's vehicles there. That's going to prove either successful or unsuccessful for the system. That's really important that we have the proper timing of those, or aim of those radars, so that we don't have those false detections. And again, there's also set up in the utility setup, the configuration. You can set up some parameters for those radars so that we're digitally excluding sources of false detections. So when you get the system all set up and powered on, it's going to put out a Wi-Fi network. It's just like any other Wi-Fi network, except it's not connected to the internet. It's really important to know you don't need internet connection to set our system up. You can use any Wi-Fi enabled device. We really are at this point recommending Android or Windows devices. Tablet, PC, or phone work fine. And you have to have Wi-Fi, obviously, with a web browser. And I prefer to use Chrome. So my go-to for setting the system up is Chrome on an Android phone or tablet. That proves to be very fast, completely reliable, and just the best rate of success for us. But you can use Apple devices. We just have our preferred system if you can. So you connect to it like you would any other Wi-Fi network. Now in this image here, this is like my phone, just a screen capture from my phone trying to connect to Wi-Fi devices. It says Chevron controller up there. It won't say Chevron controller for you, especially on first setup. I believe it'll say Signaler controller and then a random number. And random number is actually on the back of the controller as the ID. You'll have to go through the configuration setup to then change its name to Chevron controller. Password is always going to be what you see here, TR@FFI capital CALM. Oh, with a capital T, I forgot to say capital T. So take note of that. It's also in the user guide, and it's not on the device anymore. We don't want anybody to hack these systems. One thing that's really important to note, though, is that the Wi-Fi shuts off after 2 hours of being powered on. And that's to prevent somebody from walking into the system and making changes to it. The password's simple enough to where somebody could probably guess it. And so we don't want to chance that somebody could mess with the system, make changes to it. There's not a lot they can do, obviously. They can shut it down or turn it back on again. It's not really a big deal, but you never know why people do the things they do. So for security reasons, we shut the Wi-Fi off after 2 hours. You're not going to be able to get into it unless you reset power on the controller. Again, just the controller, but you will have to get up to the post and reset power to it by disconnecting the battery, or there's a fuse in there you can pull. I've had a lot of calls regarding that because you set the system up and then you go back to it the next day to go, or you install the system and then a separate person goes to set it up the next day and they can't get into it. And they're like, this thing's not working. It looks like it has power. It's because the Wi-Fi has been shut down intentionally. So keep that in mind. If you do need to reset power, again, just a really simple hard power reset there brings it back online, and you have that 2 hour starts again. Once you've connected to the Wi-Fi, you go to your web browser of choice. Again, I use Chrome, and you go to setup.trafficalm.com. Again, you don't need internet access. In fact, your phone or whatever you're using will be disabled from internet access because you've connected to the Wi-Fi of our device. Usually on like Android, I think Apple will do the same. It's going to warn you if you've connected to a network that doesn't have internet connection. You'll probably have to select to connect anyway or stay connected. If you select to cancel or disconnect, then you won't be connected to our device anymore. It will go back on your 4G network, 5G network, whatever. So you want to make sure that you do select to stay connected to our network, and then you go to setup.trafficalm.com here. And that takes you into our user interface where you can select from multiple systems. Now, our system has been developed to answer several, or be a solution for several problems on the roadway. So you're obviously, in your case, going to select the Chevron system, curve warning system, what have you. So you click Chevron, then you click the Save Continue button there to proceed to set up as a Chevron system. What's kind of off-putting is that it will then jump into a, like a next window where it's kind of gone through a quick configuration to change the device's setup parameters into a chevron system. And so you'll note here, and it's kind of cool in our user interface, it really explains what it's up to. So if there's anything that's kind of confusing or doesn't seem intuitive, just read through it, and it really self-explains what's going on. So the screen that it comes up with next, after you selected to set it up as a chevron system, again, click chevron and click save and continue, it jumps into what looks like a finalization screen. What it says though is that it hasn't been set up yet, and you have to click setup from the above menu. So if you notice across the top of your web browser, you've got several options there: setup, status, diagnostic report, contact about, and then change password in advanced. So the first one we're going to click is setup. That'll take you into the initial system operation. So you've got a couple operating modes. I haven't even pulled them up here because usually radar operated is the most used. So you'll have to select radar operated because the default is 24/7 operation, meaning that it flashes in sequence all the time. But you guys got radars, so go ahead and select radar and operated, and then click save and continue. From there, the next question is the controller attached to a chevron? In your case, it's always going to be yes. So this is the controller. Not the collaborators. The controller is attached to a chevron. The alternative is that it's attached to a warning sign. What this changes, though, is whether that device is in sequence with the other chevrons or not. So you want to click yes there, and then save and continue. The next option are the brightness settings. We've done a lot to make sure that our brightnesses are not blinding, but do get people's attention as best as possible. So you can set up the maximum brightness level in daylight. So the system uses the available solar power to measure how bright the sun is at that site, right, at that moment. So we usually set this to 100%, so it's going to produce 100% output during daylight hours, and that's when the solar panel is at 100% output. So do the signs do the same, or the flashing rings do the same. And then obviously at night we want to dim the system down because we would really blind drivers as they drive by. So we drop it down to 10% of maximum brightness at night. Again, all based on the solar panel. So if the solar panel drops to zero volt output or whatever, 0 amps, then this thing will drop down to 10%. And it steps in between. So it's not like it's 10% or 100%. It steps in between based on ambient light. I think there's 30 or 40 steps of output there that it can control, so that it looks appropriate for the setting, the ambient light setting. That's for the warning. So the first set is for the warning sign. Obviously, you're not using the warning sign, but the second set is for the chevron brightness. Go back here. There we go. So the first thing, which I don't have the whole screen here, I wish I did, I'm sorry, but basically all you need to do is select your chevron size, and it automatically populates the brightness settings based on that size. And that's going to balance proper brightness with battery usage. So you can change these numbers, but I really wouldn't recommend it. I think the default values are sufficient for 99% of installations. It's when we start getting into low power scenarios or not enough sunlight to power that system where we can change these. The brightness of the LEDs really dictates how long those batteries are going to run for. So we can drop these down. But there is also the occasion that engineer or whoever's presiding over these units wants them to be brighter. So we can do that as well with the system. Stock or default values, once you've selected your chevron size, are, again, totally sufficient for most installations. Then we've got our flasher settings. There is an METCD dictated flash pattern, which is the standard flash for these devices. Now, because they're radar activated, you can actually increase the warning to drivers. And again, this is going to be strictly from the mouth of whoever the engineer is on this project. But by default, here's where you set your speed required to activate the system. You're going to set that at 5 or 6. It's showing 15 here, but you really want to set that down to 5 in your case. The curve ahead warning sign at the speed, you don't have to worry about because you don't have one. Warning sign flash rate 60 FPM as flashes per minute is really critical, as well as the standard flash. That brings it within METCD guidelines. If you select a faster flash rate or a slower flash rate, we've excluded it from METCD compliance, as well as the standard flash setting. Standard flash is just off and on. We have some really cool like pop flashes or stepped flashes that can be utilized. but again, not METCD compliant, so we can't recommend them on public roads unless the engineer is okay with it. There is a advanced warning that if a driver approaches the system at an accelerated speed, so we can select a speed where we want to advance the warning, and we've seen that utilized so that we can increase the flash rate, or maybe all of the chevrons activate at one time. There's a couple different scenarios there that we can increase warning. Again, not METCD compliant, but a really cool feature that allows us to warn drivers that are going excessively fast. Because we know these curves present a pretty dangerous scenario for drivers. And so I think 80% of fatalities and curves happen because people leave the roadway, the edge of the roadway. And so we want to prevent that, and that's what we're trying to address with the system. So the faster they go, the worse that scenario is, so we can actually use the system to warn drivers that are going faster. Here, scroll down a little bit on that page. And that's that excess, what I've been talking about is the excessive speed alert. And that's where you can set a specific speed, and the flash patterns and all that are the same selections. Oh, right here in the middle, I forgot to mention the how long it takes for a single flash pattern to complete. So that's set to 9 seconds. Really depends on how many chevrons you have in the system, but that's basically how long it takes from chevron 1 to last chevron, let's say the chevron 5, for all of those to light up in sequence. So this is the time. This sets the timing of each, as well as the total time of the system to flash. There's one more feature I'll talk about that we'll have to cover, but basically we set this around 6 to 7. I think 9 is the maximum amount of seconds you can set a flash pattern to sequence through. So it's usually around 6 or 7 seconds, I believe. Here's your options for highlighted for what kind of flash you can activate. Again, the standard flash is the METCD compliant one. We've got Bright Pop, which kind of has a highlight right in the middle of the flash pattern. A pulse flash is, I think, a little bit faster. An emergency flash is almost like, if you are familiar with RRFBs, it's almost like an RRFB flash pattern. The flasher hold time is how long, so that's the last selection on this page, is how long the system will flash for after it's detected a vehicle. So 15 seconds seems like sufficient. 10, 15 seconds is basically you're estimating how long it's going to take somebody to drive through the curve. So you want to give them ample time, but you don't want to go overkill on it because we would drain the batteries pretty quick. So 10, 15 seconds is a great hold time for the system to activate for. Again, the system is going to continue to activate for that whole time. So it's not like it runs through activation one time and sequences one time. It'll sequence through chevron 1 through 5 and then start back at 1 and go 1 through 5 again, 1 through 5. It's a cool feature. It looks kind of futuristic out on the roadway. In fact, we're releasing a video here in the next couple of days. You guys will have to take a look at it. It shows some great applications of our curve warning systems. So now you delve into the chevron setup, and when you get to this screen, I'm sorry, not the chevron, but well, yeah, chevron setup. But basically, this is where you add your collaborators to the system. So it says add a chevron. It could also say add a collaborator there. And you click that button where it says add a chevron, and then you're given an expanding menu. So for every chevron or collaborator you're adding in, you add its ID. So again, that 123E41 is referencing back to that map you made. And you want to put these in order. So moving away from the controller, you add in each collaborator ID for each chevron. Now these are going to control, in your case, bidirectional flashing. So but it doesn't matter. So in this sequence here, your controller is at the front of this system. 123E41 will be the next one to light up. And then, but in the opposite direction, so moving a car moving, you know, in the opposite direction toward the controller, I guess is the best way to put it. This would be, E41 would be the last chevron to light up. Then chevron number 2 is number 123E92. That's right in the middle. And you could potentially add another one. I don't know how many this is limited to. Again, I think you could add 50, 60 of these, and it'll function fine. You're given the option to select whether a radar is attached. Now you're going to have to select that for your last chevron in the system. Again, this is the one that's furthest away from the controller. The controller itself has a radar on it, but then also the last chevron has a radar on it. You'll have to select that there is a radar attached to that. Once you've done all those, there's a big red X next to them that will erase that specific collaborator or chevron from the system. There's also these up and down arrows so you can reorder them. You can't drag and drop them or drag and move them. You have to use the up down arrows to reorder them. Again, this is where that map comes in really handy, is knowing the order of IDs and where they lay on the actual roadway. We'll work through this and figure out. There we go. Okay. Now, the one thing that really trips people up that you need to be aware of is the chevron subset size is at the bottom of the screen. It is not asking how many chevrons you have or how many collaborators you have. It's asking how, I'm sorry, let's see, make sure I get this right. So it is, I guess it is asking how many chevrons you have. So initially I set up my first system and thought chevron subset size meant that I wanted one subset. So I have 3 chevrons up above dictated, so those should all be in one subset, but that's not correct. The subset size is how many chevrons you want in each subset. And what this accomplishes is that you have multiple chevrons flashing at the same time. Now, it doesn't make any sense in a small system, but let's say you have 10 chevrons around a curve. You don't probably want number 1 lighting up and then sequencing all the way in through to the end to number 10. You want to have like number 1 and number 5 set up, and then those sequence toward, or individually, and then it creates groups of chevrons, especially on long curves. This is important so that the driver doesn't lose sight of the signs, because if you light up just 1 through 10 completely sequentially, they may run out of lighting by the time they get through the curve. So we can utilize this to break those big curves up into multiple groups, and they'll sequence individually, but they'll look appropriate, right? So in this case, if I have 3 chevrons, I put in the number 3 there, and that's going to allow it to sequence through all 3, and then start back at number 1 again and go through all 3. So just know you probably, unless it's a big curve with a lot of collaborators in it, you probably just want to put in the number of control or chevrons or collaborators you have here. There we go. Now, warning setup is for the last warning sign in a group, but you don't have that, so I'm just going to skip that one. And then finally, so that's gone completely through the setup. You'll get kind of a confirmation screen that it's been successfully set up and ready to use. The last thing you want to do is go to your status page. So up at the top of your menu, you've clicked setup. Now you want to click the status option, and that'll bring up the status window where you can view parameters of each individual controller and collaborator, and make sure that everything's kind of in good order here. So like looking at the bottom of the screen here, you see your brightness reading. If that's like at a 0 or at a really high number, maybe something's off with your solar panel. Light reading again. So you want to kind of go through these and just make sure everything looks appropriate. You know, the amount of voltage, battery voltage is dictated there. So it just gives you kind of a snapshot of what's going on with your system. Again, you're going to have a long screen you can scroll down that has all the information for your controller and all of your collaborators. The other options on the menu, you know, diagnostics, report, contact, and about, those are more for support scenarios, and you'll probably be guided by our support team if needed to go to those. You kind of click through. If you set up your first system and click through, there's some interesting information there. You can change the password of the system. So when you first log in, you've got to put in that TraffiCalm password, but you can change it to whatever your customer desires. Kind of a complicated reset procedure, so they better not lose it or type it in wrong, because you know, it's going to be a support call if they do. So we prefer you keep it just the stock password, but if you have to, if it's a requirement by the customer, then you do have the option to change the password. On the advanced page, there, if you click that last option for advanced, that'll take you to some of the specific radar settings that you can change parameters on. Probably don't have to mess with those. If you do have to mess with them, I would say give our support team a call. It's going to be the kind of situation where once you learn it there, you'll know pretty well how to walk through it, but it's kind of hard to articulate until you actually have a system on the roadway with a specific problem. So again, I would recommend if if radars don't seem to be working properly, or you are picking up a lot of false detections being defined as the system activates when there's no vehicle approaching, give our support a call and they'll walk you through those. obviously the first place to check to make sure that, the system's activating off the radar was that very first setting where you selected whether it's radar activated or 24/7 activated. Testing and validation of the system. We always recommend that you close a road when you're trying to test a system, but there's not really much reason to in this scenario. So just drive at it and see if it works, I guess is the best way, or observe vehicles driving at it, and that'll be sufficient validation to make sure that it is functional. That is all that I have for this presentation. You guys have any questions or any concerns about it at all?
No, it seems pretty simple.
Yeah.
I just want to walk through it and make sure, being the first time, we've never done one of these before. So.
Yeah, absolutely. I think that map is it's actually something we're going to integrate in the manual pretty soon, is for each of our types of systems, a map that you can fill in the blanks on. I think that's really critical. We have another alternative product. It's our wrong way solution, and kind of one that I've been focused on for 3 or 4 years now. And one customer had this big long spreadsheet of all of their systems. They had 17 off ramps covered by our wrong way system, and really well organized, and it really helped us navigate some complicated scenarios they had, and as they worked along, it helped them as well. So I would highly recommend doing that, and that'll get you through probably 90% of any questions or problems you might have.
Okay.
That's kind of the probably biggest takeaway. Other than that, logging into the system and getting connected to the Wi-Fi is pretty basic, pretty simple, and self-explanatory as well. So I don't think there's any problems you'll face there either.
Okay.
Karen, did you have anything else to add to it?
No, I think the only other thing that I would caution you guys that I've experienced when I've been out in the field is remembering when you're going from page to page or from section to section, if there's a save and continue button, make sure you save and continue, or otherwise you move on, and what you just did, you've just lost it. So just make sure that you save and continue. What I can tell you guys is I am probably the least IT savvy person there is in this world. And if I can program these things, then I know you guys can.
Obviously, you've never met my dad, Karen.
No, I have not. But
that's a good point, though. Yeah, it really doesn't take much technical skill to understand these systems. But that's a good point, though. You do have to go all the way through the setup for it to finally save its feature or its settings. So don't stop midstream. Even if you go back and make changes in a specific frame or specific page, make sure you continue on using that save and continue button to get all the way through the end. Don't use your web browser navigation buttons either. That might mess things up. It should be okay, but it might mess things up. It's better to use the built-in back and save and continue buttons to navigate through the utility there. I'll go back and show you where those are at. Right here, you've got a back button and a save and finish button. Those are the ones you want to utilize to move through the configuration setup.
Okay.
And if you run into any issues when you're out there, Donnie's got my cell phone number. I can certainly give you the direct numbers to our technical service guys, and they'll walk you through whatever. I've got a ton of confidence in how they'll be able to assist you when you're actually out there.
Yeah, absolutely. I will say it's probably best to give them a little warning, like if you're headed out to your first system, you're like, we might have questions, are you going to be available? Give them a call first. And I know when I was in support, I really appreciated that because I knew I was on call and ready to answer the phone for you. So even if you don't have a question, it might just be best to shoot them a message or give them a call and let them know that you will be on your way, and to make sure they're available as well. Sometimes they get buried in big projects also.
Yeah.
Physical installation of the system. I don't go too much into that in this presentation, but it's really, really dead simple. All the provisions for mounting and the brackets are really intuitive. Again, you're just going to use, in your case, either the top of post mount, or we include banding brackets if you prefer to use banding. We don't include the banding or the tool, I don't think. Is that right, Karen? There's no banding or tool included on this one? Okay, yeah.
Right.
But we do include the clips and the bolts you need to mount the devices to whatever post you're using. And when I say banding clips, I mean the banding, the brackets. I never know what the exact name of those are, but they're just little slide bracket that allows you to band it to the post and then bolt the device to that bracket. And the manual has a ton more information in it, more than you need, because it's kind of a universal manual for all of our systems. You'll actually get two manuals. You'll get one that is for the physical installation of devices, and then the other one's for the setup and configuration of the device. And the software manual, as we call it, the setup and configuration, is only included with the controller. So as you're opening boxes, make sure you keep at least one of each handy there. So those will help you navigate some of the questions you might have as well. And again, passwords and websites are all noted in those manuals. So if you guys are good, I think we can sign off here. And feel free to give me a call anytime. That number there will get you a phone system. I think there's a marketing option if you want to talk to me, but probably be better to talk to Karen or our support team there if you have any questions.
Awesome. Thank you, Andy. You guys good?
Karen?
Yes.
All righty.
All right, great.
Have a great day.
You too. Thank you.
Thanks a lot. Bye.